and then you have to type here sftp, okay, / 10.1.10.1.10.63, and the username is Cloudera, and the password is Cloudera, and then click on Quick Connect. Please accept it. And on the left hand side, on desktop, you have to go to the desktop very carefully. Look at that. On the top, I am removing everything. I am removing up to, I think no need to remove, just you scroll it up. Desktop should be there on the top. See this desktop. So you saw the desktop, and you please look that machine learning folder that I copied. It was copied to not virtual machine, right? It is onto the Windows desktop. So what I'm going to do, I'm going to move it to the right side, okay? So machine learning, and then I am moving it onto the right hand side, and just to drop it, and be careful when you are dropping. Don't drop it inside the folder. Drop it like this, okay? Look at that. If you select something, it will go inside the folder, you will not find it. Just drop like this so that it will be available outside, okay? While that is copying, you can eject if you have already copied to your local system. So I am ejecting that. No problem. Now ejecting, and machine learning. Oh, sorry, that folder, that one you have to do, and then click on eject. Once you get safely removed the hardware, then you remove it so that other people can copy. While the copy is going on, let me tell you what is there, okay? Or even though the folder name is machine learning, there is another important document I kept inside, okay? That is on HBase. This is the last component that you need to know in Hadoop technologies, okay? What is HBase? We already know what is HDFS, and we already know what is Hive. Of course, MapReduce and all are the other formats, other programming things. HDFS is a file system in which you will have 128 MB blocks. It is divided. Name node will manage the data. Data node will store the data. MapReduce will go to each node, execute the things in parallel. Facebook faced the problem of dealing with this MapReduce, so they created a data warehouse or lab on the top of HDFS, which is nothing but the Hive. So Hive is OLAP, not for transactions. And then we studied partitioning and all those kind of things on Hive, right? And Hive supports Hive query language. We have used Hive JDBC, and we connected it, created the report, created from Excel, everything I have shown you. Where is the OLTP part of Hadoop? That is the question now we are answering. OLTP means transactions, very fast access. Thousands of concurrent users are querying, updating the data. That is what HBase is all about. So OLAP, analytical part, is Hive. The transaction part is this one. So this is OLTP and this is OLAP. Remember the basic differences. When to use what? What is the answer? What is the question that you are going to use? Are you going to run report? Are you going to create dashboards? Are you going to analyze the data? Then Hive. Are you going to use it for real-time update? For example, I want to know my credit card transactions in real time. I want to query, I want to get it, I want to update it. Okay? Now comes the next important concept. This is a NoSQL database. Everything arranged like your RDBMS, rows and columns, correct? Remember your My Schools table we queried and all, right? So it is like RDBMS, where rows and columns are there. This is a columnar database. The first time you are hearing that word, what is meant by a columnar database? What is the difference? Can you guess by the name? What is meant by columnar? Is Oracle a columnar database? No. Is MySQL? No. It is all like Hive. It is like RDBMS databases. What is a columnar database? Consider rows as columns and columns as rows. That's called a columnar database. If you know mathematics, what is it called? Transpose of a RDBMS. Remember the matrix transpose? Right? Rows will become column and column will become rows. Exactly that thing. What's the advantage? Fast querying. So trillions of data is there. It will be very easy to query. And that's what HBase is all about. In HBase, unlike all the concepts, no need to know all these things. There is a master server and there is a region server, just like name node and data nodes. Master will take care of how the regions are being split. Okay? There is one disadvantage for HBase. HBase will be very fast if you are querying by a row ID. I'm going to tell you what is row ID. It will not be fast if you are querying for a particular column. Because of that, it is not getting a very wide acceptance in the community. It is fast only if you query by row ID. Now let me tell you what is row ID. Remember MongoDB? Whenever you insert a particular document, a JSON document, what is the automatic field that is created in MongoDB? If you have observed that time, it is called an object ID. There is an ID for everything that you insert. I have shown you that. Okay? In the similar way, whenever you insert something into HBase, there is something called a row ID. That row ID normally will be a primary key of your particular table. So that row ID, using the row ID, if you query, everything will be perfect. Fastest query result you are getting. For example, a customer ID, customer name, customer age, customer salary, or customer occupation. You have all these particular fields. Assume that customer ID is your row ID. And you are querying by customer ID. Ultimate, there is nobody who can beat HBase. You want to query or search by customer name, gone. Then it will again go back to that, the old style. So please remember, HBase is very fast, provided your queries should be based upon the row ID. Okay? So, since it is successfully copied, as you can see, you should not be getting failed transfers, anything. Only you should get successful transfers, which means that everything is transferred completely. Okay? So, come back here. I am going to switch off this FileZilla. We don't need it because we already copied it, and you have a copy on your this one virtual machine as well. And what I want to do is, if you go to that particular folder, okay, I'm going to use the File Explorer. Have you ever used the File Explorer on this Windows, on this one? So if you minimize all the windows, you will see My Computer. Look at that. And if you click on that My Computer, you will see File System. And in the file system, if you go to Home and if you go to Cloudera, and if you are looking at that, there will be a folder called Machine Learning, which is just copied. And inside the Machine Learning, look at that. This is the PDF document that I told you. Just double click that and open that real HBase, the OLTP on Hadoop. Okay, there is a brief explanation given, which I have already explained to you. What is HBase? And just to show you a picture, if you are scrolling down a little bit, please look at this. See, there is a column and there are some data, right? And wait, I will show you. Okay. Just give me a minute. I'm just finding out the picture. Stuck. I have a copy in the foroursun.com also, so I am going to open that copy, foroursun.com/passion. And if you are going, the real HBase OLTP, you will see that same copy, okay, here also. Okay, so if you come down and if you look at the first diagram, you will see how the normal table is being represented. Look at that, okay. Let me make it big. How is it? Zoom.
Behind the tree.
Please look at that. So column and row, you know it very well, right? This is how normal the tables are being represented. Now if you come down and if you see, look at the way in which HBase is representing that particular data, okay? You will see some very important things here. This is the what I told you as row ID, okay? A timestamp is automatically added. See the beauty here. In analytics and in retrieval of the data, what is the most important thing you need? Last 1 month data, last week's data, yesterday's data, last 6 months data, correct? So if you are able to segregate whenever you are inserting, assume that you are putting a timestamp also, without your knowledge, hidden. And when you are querying now, give me last 6 months of the data, because the timestamp is there, HBase will give you the data, boom. Right? So it will add a hidden column called timestamp. Then you will see something on the top. This is called a column family. What is a column family? All the identical columns can be combined together and kept it under one column family. So customer is a column family. So if I have customer name, customer age, customer salary, customer occupation, all these can be combined into one column family called customer. And now I have got entirely different data, account related or order related, right? I can combine all these and I can tell that it is a column family. So a column family can internally contain many columns. Which columns? The columns of your relational database table, right? What is the advantage? See how the data model can be represented. Assume that today you don't have HBase. How will you represent all these things? Customer will be one table and there will be a primary key. Accounts will be another table, there will be a foreign key. And then there will be orders which will be having another key. And then will be order items, there will be another key. And you are going to join all these things by killing your data warehouse. Look at the join speed, join complexity, right? You will have to do the cross join of all the data. If there are m rows in one table, n rows in another table, your total number of rows is going to be m into n. So you multiply it all, you will get a very big data as a result, which is very, very difficult. How they have eliminated it? They are telling that, okay, represent it in one table. So bring your customer data, account data, order item data, everything, and then create column families and put a timestamp whenever you are inserting and search by row ID. That's it. That's what HBase will do. Okay. And if you are interested in installing HBase on your Mac, there is instructions given. Now you are well versed with all these things, but I don't suggest you to do that if you are not familiar with it. Otherwise, just come down and then you will see. If you come down, the point from where you can start on your cloud or a virtual machine, that is page, this one. What is that page number? 13. Okay. Use HBase for the first time. Connect HBase. So please look at some of the commands that you need to execute first. Sudo service master stop region server stop, and then delete all the directories that are used by HBase so far, and then start both of them. So I am going to do all these things one by one. I'm going to open the virtual machine. Okay, let us close this thing because this is not working. And in the virtual machine, okay, close all these things. We don't need this, right? And open a terminal. This is the terminal you have, and keep it on the right hand side, this side, and then go to the first command. What is that? Sudo service HBase master stop. Why sudo? Super user, right? Sudo service HBase master stop. Sudo service HBase master stop. So it will give you a message stopping master. Why? Because in Cloudera virtual machine, everything will be running. Look at that message. After that, what you are going to do, again, do the same thing for region server stop. Okay, region server stop. So sudo service hbase region server stop. Spelling mistake. I think it is region server. It's a single word. Okay, there is no dash. So region server stop. Look at that. And then sudo you have to delete the hbase directory, and that is available in /hbase. So Hadoop fs minus rmr, you know the command, /hbase. No sudo needed there. Hadoop fs minus rmr /hbase. What I'm doing is I'm doing a cleanup. Okay, and then you do the reverse. First, I think you have to start the region server. Oh, sorry, master, and then the region. Okay, so let's start the master. So go back again, the first command, and then write start. Oh,
But it, okay.
sorry.
Master.
Master, start. So it's starting the master. Yes, and then start the region server. The region server is also started. So these are the minimum steps that you should do before you are starting your HBase. Clear the screen, and then please type HBase shell and press enter. So you will see the OLTP screen is coming. Unfortunately, SQL will not work. Don't think that SQL is going to work. Why? Because the table structure is completely different. It is columnar. How can you write a SQL statement, right? Look at the prompt that you are getting. This is how you will be getting the prompt whenever you are starting HBase. And then what you need to do is go back and let us create a table. Okay, create test CF. Look at the command. It is not create table values and all those things. Can you guess what is the meaning of that? Test is the name of the table, and CF is a column family. Remember I told you about column family? So everything you have to give in single quote. So go back to your virtual machine, create, okay, test, comma, a blank column family, and wait. If everything you have done perfectly, you will be getting a message that it is getting created. There is an error. 1 minute. Server not running.
Name node is also in safe mode. When you try to delete that directory HBase,
Oh,
that time it gave message name node is in safe mode.
it give the message?
Yeah, it gave
Okay,
message.
let me do one thing. I am going to stop it. My dear friend, you are sitting near me. HBase master stop. What is the command, Sheetal? For the region server, sorry, for the safe node minus leave, DFS admin, right? What is the command? Hadoop DFS admin minus safe mode leave. No. What is the command? HDFS
Hadoop DFS admin minus safe mode leave.
It's not leaving, no. Yeah, now it is correct. And now let us do sudo service hbase region server stop. Master I already stopped. No region server is there. And now let us delete Hadoop fs minus rmr slash hbase. Okay? Now, no error. Let us try to start it. Hbase master start. Okay, and hbase slash region server start. Okay, clear the screen, and now hbase shell. Okay, and then create test, comma, the column family which is CF. If you get the error, that means safe mode should not be leave. Okay, it got it. How will you know how many tables are created? List is the command. And you can see now there is a table that is getting created. So please practice on these commands in which you are creating multiple column family. Everything is written here. Okay, just execute the commands. I have given the screenshots also. What is most interesting is the last page. If you see, remember our scoop import and look at that command. If you write Hive table, it will create the data on the Hive table. But if you write Hive table, HBase table, what will happen? It will create the complete data from MySQL on HBase. But you have to provide what is the column family and what is your row key. Understand? Because it is HBase, correct? So if you do that, your scoop import will work. This is what we are doing for every table there, right? Every day running the data, taking it from the databases and putting onto HBase, and they are connecting from the Tableau and other reporting tools into HBase. Now, one more question, again, outside the complete course. How will you connect to HBase? Is it HBase SQL compatible? No, right? So is there any way that I can connect to HBase and create a report? It is not SQL. That is a good answer. Presto you can use, or please look at this. These are all some extra information. If you want, just note it down. Okay. Apache Phoenix and press enter. See what these people have done. If you look at Apache Phoenix, OLTP and operational analytics for Apache Hadoop, what they have done is that they have given you a JDBC driver on the top of HBase so that you can completely read and you get the full ACID probability. This is what I'm using for Presto. In Presto, they have created a connector to Phoenix. What does that mean? You can join HBase, MySQL, Kafka, all these things I showed you. And what is the advantage? You don't need to use scoop. Why? Remember, create table as select star from. If I write in Presto, Presto will automatically create it in HBase. Okay? So, remember this and please do practice on HBase. Right? Now, go to the second folder. There is a nice PPT. And that PPT is no way meant for this particular class. It was a long 2.5 hours of seminar that I have taken some time back on. You didn't copy everything? There is no PowerPoint?
I don't know.
Not there? Okay.
Collaborated file training and recommendation.
Yes, that's what I want to open, but I can't open that. Can anybody's machine you can give? Now, all your, this one will go. What to do? You have PPT?
We
No.
have
There is a problem with that.
Yeah.
think
There's,
we have,
ते आपलाच दे ना मग.
but it's shared email.
ते बंद होणारच नाही मग. त्या
It's
recording
called
चालू
dollars
करू
and
शकतो.
file.
That is because it is not copied. The real file was not copied. Let me see whether I have a backup or not in my system.
Copy
PPT
केलं.
फाइल नहीं कॉपी नहीं किया.
Copy केलं ना आता.
I didn't copy it.
Local में clear केलं ना.
There is a PowerPoint in that floppy disk, in that drive, and in that drive, in that PowerPoint, that is a PowerPoint that I have taken for a seminar. So please look at this. If I go inside my data directory, machine learning, collaborative filtering, and if I double click open, you will see that it's a very nice presentation to give you the fundamental of machine learning. Presentations, collaborative filtering. So this is exactly the file that I have given you. If you have not opened, you are not able to open it, you should be able to open it if you are copying it well. Right? No? Okay. Can you go to 4hoursun.com/passion and there is a machinelearning.zip there in the 4hoursun.com/passion. Can you download that one? It will be there inside this. Okay? And please look, don't go through all these things. It's a purely mathematical thing. I don't mean to take this particular thing. If you have studied all these things, you will be remembering. What is De Morgan's laws? Anybody? You have heard about De Morgan's laws?
Don't remember.
Union of an intersection equal to intersection of the unions. And intersection of a union equal to union of the intersections. Okay? Intersection of a union equal to union of intersections. Similarly, intersection of a union equal to union of intersections. That is called De Morgan's law. It is one of the very famous laws in set theory. If you go through, you will see a little bit of history of what happened in the machine learning, etc., etc. It's a nice deck just to go through this particular thing. So this was a 2.5 to 3 hours of discussion on machine learning in 2013 or 14. Okay, just to give you this brief idea. And you attended my neural network also, right? So this is what I was talking about all. What is machine learning? In machine learning, you have data. The data goes through a learning process, just like your child is learning. Just think about your child when you think about machine learning. How the child, after birth, going through so many cycles of discussion with you and finally tells you 1 plus 2 equal to 3. That's exactly what is machine learning is all about. It goes through a learning process. And in the future, you give your child any question, the child will look at what has been learned and will give you the result. Correct? That's what machine learning is all about. And let us take an example. The example is this. I have got some basketball data. And what I want to do, in the basketball data, I am looking at the history. What is the history? When this match was played, okay, 7 p.m. I am looking at the first row. Where the match was played? Home district or home state or away? So home state. So there is a good player who starts the game. So Fred started the game, yes. And Joe's offense is another attribute. Joe is another player, so who is playing opposite to Joe, like who is playing opposite to Messi, we ask that kind of thing, right? So Joe's offense is center and Joe's defense is forward, and opposite person who is playing in one particular section is tall, and the history says that that game was a success, win, right? Are you following? Second one, almost all, but this opposite guy was short, but still we won. You have got historical data. This is the most important part of machine learning. Machine learning, you will pump the data and you will tell the computer to analyze the data and find a pattern. And it is very difficult for the human being to do it. Look at Amazon. Millions of things, millions of users are buying. But the moment you are logging in, it is telling you recommended for you, correct? See the beauty of that analysis, right? So, if you have this particular data, can you give me the result of this? You will start thinking, I know, he's eager to give the answer, right? But the problem is, if there are 500 columns, if there are 2,000 columns, or like Amazon, if there are 1 million columns, how are you going to give the result? You know what is the biggest problem here? Why you cannot give a result? Okay, you will tell, okay, suppose Surya is telling me that if we play away and if we play at 9 p.m., we may win, something like that, right? But that if we play away, why did you take this column? Why are you not telling if Joe's offense is center and if we play away and if Fred is starting, then we will win? How will you, out of all these things, which is the first one that you are going to tell?
Lesson.
Are you understanding?
Yeah.
So if you create a tree, what is the problem for our tree? Where to start? Is Fred started is the first node? Or is the play was home or away is the first node? Or is Joe's defense is the first node? Was it raining is another this thing? Is it happening at 7 p.m. or 10 p.m. is the, right? Where to start? Okay, assume that you started, okay, after analyzing all the data, I found out that, okay, if the play is away or home is the node, but what is the next node? Again, you are having the same problem. Right? And another thing, how long you will travel? Will you 1 million columns are there? Are you going to analyze all the 1 million columns? Or are you going to analyze 10,000 columns? Or are you going to analyze 50,000 columns? Beautiful science, right? Please look. So, how will we solve it? What you need to do is go to your virtual machine. I'm coming out. Go to the machine learning folder. Go to another tool that I'm introducing to you. What is it called? Weka. What is this Weka? Very nice name, right? Weka, University of Waikato. And then press enter. And now please look at this screen. It's a beautiful little bird in New Zealand. Waikato is a university in New Zealand, just like we have our Ivy Leagues in a similar way. It's a beautiful, fantastic university. Like R, for machine learning, this university has created a tool which is codenamed as Weka. And Weka is a bird, small bird. So they gave that bird's name, and it is a fantastic tool for machine learning beginners. Why I am telling you machine learning? Hadoop itself, the salary became 150,000, right? After Hadoop Presto also, now your salary is 180,000. So if you add machine learning also, it will be about 220 to 30,000. Right? So that is why I told you about this particular tool. So start learning this. Just install it. And I am giving you that Weka jar file. All that you need to do is go inside that particular folder, Veka, and then type java -jar veka.jar. There is a file. And press enter. A little beautiful cute bird will come on the left hand side, and that shows that Veka is started. And what I'm going to do is click on Explorer, and after clicking the Explorer, click on Open File and go to that machine learning folder, and inside the machine learning folder, please make sure you are selecting all files or CSV files, and you will see the basketball statistics.csv, which I have just given you in the PowerPoint presentation in a CSV format, comma separated value file, right? See, immediately when I click on OK, what is happening? It will do an analysis and it is going to give you immediately a graph. Whether it is 1 million rows or 10 million rows or 20 million rows, it is going to show the immediate graph. Okay, it is telling that there are two categories, win or lose. Blue is the win and the red is the lose. Okay, I do it for claim analysis, for example. How many rejected, how many pending, how many are this thing, right? I can just query it in a fraction of a second. I can use it for fraud detection. If millions and millions of transactions are there and you want to find out how many of the frauds or how many are getting rejected or accepted or kind of things, you can do it. If suppose you are in a hospital and you want to look at the entries coming in with a valid insurance, you want to find out how many are valid, how many are invalid, you can use this. That's the beauty. Immediate, quick analysis. And then what I'm going to do is, I'm going to do a classification algorithm onto this particular file. Click on classify, and I'm going to click on choose, and I'm going to select an algorithm called a decision tree, and that is the tree that I want. And there is nothing called a decision tree in Veka. It is called J48. So I selected J48. You may ask, what is J48? Actually, decision tree algorithm, it was earlier called, the original version was called ID3 algorithm. Okay, icotomycer some full form is there, very complex. ID3 algorithm. It was open source. Suddenly that inventor, what he did is he made that open source to commercial version, so nobody could use it. So this University of Waikato has created a Java version of that ID3 algorithm, and that Java version is called J48. So that J48 algorithm I have selected, and then I am going to click on the start button, and on the right hand side you will see innumerable calculations are happening, and you got the result already. Okay, now what I want to do is that, hey, this is not enough. What I am going to do, click on, okay, sorry, I am going to make a right click on this particular thing that I have done, and I am going to click on visualize tree, and please look at what you are seeing in the right hand side. A new window, and you got a particular tree, and applying the machine learning algorithm, it has found out that if Fred starts, if the answer is yes, if the play is at 7 p.m., 5 p.m. or 8 p.m., depending upon that you can decide. If the Fred is not starting, then please look at, what is that? Whether we lost or not. We are lost if Fred is not starting the game. Understand? Now you will ask how we calculated this. If you look at the mathematics and statistics behind this, better you will not be able to use it. And there is something called entropy, there is something called information gain, there is complete mathematics involved inside that. And even if it is 8 fields, it will take about 5 hours for you to calculate each and every field. And automatically the tree is being painted for you, ready to use. This is the fundamental idea of machine learning. So what we have done today is we applied a classification algorithm. And the algorithm that we have applied is called a decision tree. This is the one which you grow into the top-notch levels of what is there in the industry, where you will go to neural networks, artificial intelligence and all. But for now, start with, if you have 20 columns and if you have some data and you want to show your boss that this is my analysis about this particular data, see how simple it is. right? Everything is there. And there is no Hadoop or nothing needed. You just need that webcard.jar file. Just copy that whatever I have given and then just put it. Otherwise, go to that site which I have told you and then this one. And it is not that simple. Please look at that again. If you look at choose and if you are seeing that there is base, naive Bayes algorithm, there are a lot of functions, there are lazy algorithms, there is machine learning algorithms, there are rule-based algorithms, and in trees itself, binary tree, so many algorithms are there, at least 70 to 80. Now, what is the relation between a Hadoop programmer? Okay, please look at this again. There is more options, and if I am clicking output source code, the last one, see, it was not checked. I am checking it, and I am going to click on OK, and I am going to do a start again. You will now see on the right hand side the Java program to calculate this particular thing, not the visualization. And now tell me, if you have a Java program, what you can do? You can easily take it and run it as a MapReduce program on millions of nodes or thousands of nodes, so that if your data is not 10 rows, but it is trillion rows, it will now run the algorithm on MapReduce. And that's what we studied in our MapReduce programming, where you have a jar file and you submit the word count jar. You create the jar file with this Java code and submit it so that you get that particular output. Right? Finally, there is one more program, okay, that is how Amazon finds how to recommend the product. I'm giving you that one also. I'm using another library, a little bit old library called Mahout, M-A-H-O-U-T, in order to do that, okay? So this is what I want to do. If you are reading this and if you are going this way, you will see that I have got this particular diagram. User 1 has bought 101. User 5 bought 101, 104, 105 and 106. These are all different items. Okay. BMW, Porsche, like that. So user 3 has bought these 3 items. User 2 bought only 1 item. User 4 bought these items. And you have got the rating given by these users. So for the first item, 101 has given 5.0 rating. For the first item, 102 has given 2.0 rating. Understand? So I have got ratings as well. This is what exactly you will do in Amazon. And now my question is this. Please give me the answer. What is the item that you will recommend for user 1? Because user 1 bought which item? 101. Don't look at the dotted arrows. Okay. So user 1 has bought item 101. I want you to look at similar users and tell me the answer. Who are all bought 101?
User 4.
Okay. User 5 also bought, right? Okay. And user 5 and user 4, if they bought 101, what else they also bought? 104, 105 and 106, correct?
103.
Not 5.
104 and
103
103
also, na?
Yeah, 5.
Okay, so which is the item that you will recommend?
104, 105, 106.
Only one item.
No.
So what is the maximum proximity?
104.
104. Beautiful, right? Now you understood the difficulty. If there are 20 items like this, if there are 20 users, gone. Machine learning, mathematics. What you need to do is come out, go to back, and you will see Mahout code ls, and you please look at this file vi intro.csv. okay, vi intro.csv. This is exactly the file that I have given there. Oh, you are not able to see that. You have seen that file, right, in the PowerPoint. That's what I have given you here. Look at this. That's a while, right? And what I'm going to do is I'm going to run the command. Let me look at what is there in the build.xml. Vi build.xml. Remember this build.xml? In build.xml you will have all the options, and then there is the first one which is called and run one. Okay. And I'm going to do the and run one. And what is and run one is doing? It is going to recommend a product for the first user and press enter. So it will read that intro.csv and it is running it.
And
rm minus rf classes, because I run it in Java 1.8 in my machine, and you know that in Cloudera it is what? Java 1.7. So I'm deleting all the classes and compiling it again. All this you should know, man. You have seen more than enough. Look at that output. It is running and it has recommended the item 104 with a probability of feedback from the user as 4.25. You increase that to 1000 items and run the product, then you will see, run it, then you will see the beauty. Right? This is what exactly, it is not a out, but it is exactly the algorithm that is used by Amazon. And that is how it is predicted. There are two ways you can predict. We used user-based recommendation. Another is there, item-based recommendation. What is item-based recommendation? If you bought a book on how to machine learning, there is a possibility that you may buy a neural network. That is item-based. What is user-based? If Surya has bought a machine learning book, surely Suresh might learn a machine learning book while both of them attended the same class, for example. That is user-based. We applied user-based. Okay? Now, what Amazon is giving you both. Why? Amazon recommends this item for you. That is item-based recommendation. Another one also you will see in Amazon. Users who bought this item also bought this item. That is the two different ways. Clear? 2 more classes I will give you Spark. Okay? Machine learning, base, Hive, MongoDB, reporting, R, Weka, Presto. It will blast now. Okay, so please practice this. Come Tuesday, right? Will you do? Please do this, right? It's recorded fully.
Yes.
Do they analyze then how many